So hello everyone. Today is actually December 8th, but I wasn't able to film this yesterday, although I took a sneak peek on what the actual problem is. I have a clear understanding of how to solve it. I've actually solved it on the test case, but this time, instead of going deep into just solving it, I think we're gonna spend some time on thinking about some of the features of the programming language NIM, because after all, for me, the advent of code is about solving these challenges, brushing up on data structures and algorithms, but also about learning NIM, the new programming language that I'm learning during this episode. So let's spend some time on that as well today. But first, the problem. So the problem is no space left on device. Boy, haven't I heard that before. So we have our input this time is this basic, we're traversing like files or directories and files in the terminal. So we get like, okay, cd to the slash directory, ls. So then we can see what is in this directory. Then we cd into a, ls, and so on. And then we can also go up directory. So these are basically the basic commands. This challenge is actually quite easy to understand, but as you will see, this is the implementation. Yeah, this is going to be good. But yeah, so also here back on the drawing board, because we always need the drawing board. Let's see a sort of quick image of how this could look like. The image and the text do not correspond in any way, by the way. So we start from here. Let's say this is like the home directory. Green boxes are files and blue are directories. And every time we see a blue box, then we can sort of sneak peek into that, what's inside of that directory. We have two files, one more directory. Inside that directory, we have two files. And so you can see sort of like the file structure on a computer becomes this like tree that we have to sort of traverse down to see how far do we go. And then we have to go back up. For example here, and then we go to this file, and then we go traverse down that sort of that branch, if you will. And here, since we have no space left on device, the question is, what is the sum of the total size of those directories? Those referring to with the total size of most, what is this, 100,000? Yeah. Exactly. And subdirectories included. So this will be the question that we're trying to answer. So basically, based on this, we need to make a mapping. Somehow we need some structure to understand how all the directories are connected, and then we just need to record the file size, which is the number here of each of the files. And then, for example, if like this is 1 and 1, then for example this directory would have size 2. Directories themselves do not have are not considered to have any size, like here it says directories themselves do not count as having any intrinsic size. Perfect. So now that we understand how this works, let's move from the drawing board to the code, but let's not completely, let's straight jump to solving this. I'm gonna show you a few concepts in NIM that are gonna help us to make this solution elegant. So let's do that. So the first thing I wanna talk about is objects and overloading. So let's create an object, file with a name, which is a string, and with a size, which is an integer. And then we can create a file. Var f is a file, and then we say f.name equals home, and f.size equals 1, or no, 2. Yeah, let's do 2. And now we would like to have a way of printing f in a specific way for us. So we can of course just do like echo f, and it will give us something nice, or something like just default. But maybe we want to have something a bit more complicated, or something like according to our formatting standards, or let's say in case the file would contain some other complex data type that wouldn't be able to represent in this clear way. So let's talk about overloading functions. So like in C++, you can overload functions. So here, for example, we can overload this function. So this is like a general, we can hover over here. So it's a generic operator, yeah, that always like stringifies, and you'll always be able to print out things if you put the F or like the $sign there. So now, but now we can modify this and sort of like create like our own way of printing stuff. So yeah, now we get, when we echo F, it gets formatted according to the way we want to be able to format things. And this actually might come quite in handy when we're sort of like, let's say that we want to be able to print the contents of the directory, including all subdirectories and their files. So now we can, instead of every time just like having our own print functions, which I think we had in some last one, so we can just call echo F, and then we can overload this function to actually recursively go through all the subdirectories. So that will be quite nice. So the next thing I want to talk about is memory management. So we have this var f, which is a file, and this one is actually stored on the stack. But if we do like this, var f2, a new file, and we peek on this, it says that it's a ref file. Where if we peek at this, like just for comparison, this is just a file. So what's actually going on here? So the thing is that when we instantiate a complex data type, oh, it actually says here, and returns a safe traced reference as a result. So F2 is not the actual object, it's a reference to the heap allocated memory in where the actual data lies. So this is allocated on the heap. And this is quite cool. So depending on how we instantiate an object, we can either have it on the stack or on the heap. I think in most cases, this is actually what you want, and this is exclusively what you want. So there's a shorthand or sort of like a faster way to do this. So we can just modify the file object itself to say that file is always, so the file data type is always a reference to a object. So now nothing changes. Basically, now this just says file, but what file means has changed. So now this actually, instead of being allocated on the stack, this is allocated on the heap. And now this is, if I understood correctly, the Nim documentation. Now, and on to the actual challenge. And as I said, I've already done some of the parts, so I'm gonna like partially recreate some of the stuff I've already done, but I think I'm gonna do it in a different manner. Let's see how this goes. So, besides of the file, we also need like a directory, and that's also gonna be a ref object. So, and the directory is gonna also have a name, which is a string, and then it's gonna have some files, and that's actually gonna be a sequence of strings. So, oh no, not strings, it's gonna be a sequence of files, of course. And then it's gonna have some children. So this is how we do this, like in case there are directories inside of directories, we have this, the directory has this children key, and within it we have a sequence of other directories, like this, and then here we have a typo. Like that. So these are the two basic data types that we're gonna work with. Directories, and this is like, if you like recursion, you're gonna like this assignment. What we now can do, we can say like home.children.add pics. So what we've done here is we've instantiated the home directory, we've added some files there, we've instantiated the pictures directory with some files in there, and then we can say home.children.add, because remember, children is a sequence, and we can add directories into that sequence like this. So now what we've done is that we have like the home directory, and we've added the picture directory as a children to that. So now let's also print this in a beautiful manner. So let's do that. So now I have here the overridden procedure for printing a directory, and let's actually walk through this line by line very slowly, because if you understand how this works, then you will understand how this whole assignment works, and yeah, things will be just a lot easier. So yeah, we just take in the directory and then the depth, and the depth starts at 0. So when we start at the home directory, we're sort of at the highest level, and then we just set current depth to depth, and then we say we want to have tabs, and we want to repeat them for as many times as we have what the current depth currently is. So in the beginning, this is just nothing. And what we then do is to say result. Remember, result is the string that this function is going to return. And it starts with tab, which in the beginning is 0, and then the directory name, and then we just put a new line character afterwards. So when we start, like at the first iteration, when we start at home, the depth is 0, so this is nothing, and the only thing we append to this string is the directory name, and then just new line. All right, then if there are any files in this directory, then we want to put those files underneath the directory name. So we just say like, hey, whatever result previously was, which is the directory name and a new line character, let's also have the same indentation as we had previously, and then we're just going to put file name and file size, and then a new line character. So if we have several files, they sort of like get stacked underneath. And now that's sort of like, that's all clear and good, but now comes the tricky part, the recursive part. So now, if this directory has any children, so in our case, we are in the home directory, and we have one child directory, which is the pictures. So what we then do is we increment current depth, and then we say that for all the children that this directory has, let's call this very function. And this was actually a trick that was like very unintuitive, but because we have two parameters to this function, this is actually like an operator. So we take this and sort of like operate with that. So this is the directory and the current depth, and this is sort of like the syntax that makes this work. This was definitely not intuitive for me, and actually I struggled a long time because of an error at here. But never mind. So we recurse this very function, and then this returns whatever comes from this recursion, and then we just add that to the result. Okay, and now when we echo home, what we get is this. So we have the first thing it printed out was the directory name, which is home. Then it printed all the files that are in there. So we had, remember, we put in hello.txt and chow.html and their respective sizes, 1 and 2. And then within home, we also have another directory called pictures, and pictures contains an image.jpg, which is of size 12. So, and now you can see here comes the tab in place because current depth is 1 when we go to pictures. We are recursing down one level. So if you understand how this works, then the assignment isn't gonna be that hard. So the next thing we're gonna program is the sum of the directories. So we'll proc sum dir, and this is gonna take a directory like that, and it's gonna return an integer. And then we can just say like, yeah, var sum equals 0, and then for file in dir.files, we just take the file.size and increment that with that. But then if dir.children.len is more than 0, so saying that if there are subdirectories, then because no, wait, children, yeah, okay, so we have to do for child in_children, because that's yeah, a sequence. And now we can do sum is plus equals sum of the child. And again, the recursion part. If this directory has any child directories, then we go through each child, and then we call again upon, like the function calls upon itself, and then tallies up the sum and then returns. So what we can now do here, let's just maybe check that it works. And now when we just echo home, yeah, we get home has size 15 and pictures has size 12. So yeah, this works. So I'm taking again in the test file here, and what I'm thinking is that we have these commands. So I think this would actually be maybe a nice thing to have. So let's say we have a type called mode, which is an enum, and it has mode, which is cd and ls. Is this wrong? Should it be the other way around? Mode equals enum, yeah, like that. And then we can, in the beginning, we can set var mode equals just mode. Do we have to initialize it? Oh yeah, exactly, this has to be like that. And no, it's not, it's of type mode, like that, thank you. What do we have now? So here, so far, what I've done is that, yeah, first of all, let's just break when we hit this line. So that would be here. So we're just like going through the home directory. Let's make sure that works. And then if we are in ls mode and we are not on a line that has a command, we're just splitting it. And then if we encounter dir, then we create a new directory, set a name to it, and then we append it to the current directory. So just outside of the loop, I created this home directory. I'm not sure if this is necessary, but for me this was like a nice way to do it, because we have to keep track on what is the current directory when we will go like down one level or up one level or so. So yeah, if it's not a directory, which means that it has something else in the beginning, then it means it is a file, and then we just parse the size and the name, and then we just put that file in the current directory. So that's where I'm at, and that seems to be working. So one thing I realized I also should implement is a parent, and the reason, make the error go away, is the reason is that when we go up one directory, so then we would like to know, as we have traversed down, we would like to know which directory was the parent to go up to, like that. All right, so now we have something. We have home, which has this size, and this should be what they say here. The outermost has this size, which is 43, yeah, that's correct. And so on. That's also, let's check some, yeah, that's also correct. So it seems that this is surprisingly working. This turned out to be quite a behemoth of parsing this whole thing, and yeah. All right, let's just read in the real input file and see what happens. Let's see what happens. I'm just gonna call turkey input.txt. Let's see, how long does this take to... Okay, actually not, it went quite quickly. And this is the directory structure that we get. It's beautiful, it's one humongous tree, and it says that we have 151 directories. That... No! Answer is too low. No. Okay. All right. So we were not supposed to return the count of the files. We wanted to, what is the sum of the total sizes of those directories? Incredible, incredible. Okay, now we're getting something like, yeah, like that. Let's see, let's submit, and yes! Ah, finally, finally. That was, yeah, yeah. Let's just go to part two. So we have to take the okay, so I think at this point I'm way too tired to actually do this properly. Let's do it like that. So this is actually not, this is definitely a bad way to do it, but yeah, this is what we're doing now. So if I equals real, just echo hi. So yeah, I completely misunderstood the whole thing, and that would return. Yeah, well, actually, I don't think we need to do this. I think this is already the correct one because it, yeah, it returns that. And then we can do input dot that, and yeah, now let's see what it gives us. It gives us this. So, and finally we have it. So yeah, what I completely misunderstood was how to think about this. So we actually wanted to have this like needed space. So we have how much space we use currently, the total space, and then the required, and then we should calculate how much is unused, and then take the difference of the what is required and the unused, and whatever is closest to that is what we should delete. That's the directory that we should delete. So yeah, what did we learn? I think we learned a lot today. So this has been, I think, so far the challenge where we most used different features of the NIM language. We have enums, we do overloading, we have objects, and we talked about how you can sort of specify the memory management. Is it stack or heap allocated? Or like with this ref keyword. We also quickly touched on using unsafe traces, which is pointers. I'm not going to do that, or I don't think I'm going to do that. And I would suggest also you not doing it unless you know what you're doing. But yeah, quite tedious, but fun nonetheless. And today in the evening, I will still do today's. So stay tuned for number 8 as well. Ciao.